The temperature inside, 50 degrees Celsius. The visibility, 12 degrees forward, 0 degrees everywhere else. The escape route, blocked by your own ammunition. Oberleutnant Hans Frick sat in the fighting compartment of Ferdinand No. 501, and in this moment, July 10, 1943, watching Soviet infantry emerge from the smoke with satchel charges, he understood something his commanders would take months to admit. The vehicle they had called unstoppable, the machine they had told him represented the pinnacle of German engineering, had become his coffin. Not because the enemy had destroyed it, because the engineers who built it had forgotten that men inside tanks need to survive contact with reality. This is the story of the Elefant tank destroyer, Germany's heaviest armored fighting vehicle, to see combat in World War II. But it is really about what happens when ideology demands perfection and engineering delivers a machine that excels at everything except keeping its crew alive, and what it reveals about the distance between what institutions tell themselves they have created and what they have actually built, between theoretical invincibility and the moment a Molotov cocktail hits your engine deck and you realize there is no way out. July 1943, the Eastern Front. Germany is preparing for Operation Citadel, the offensive at Kursk that will involve more armor than any battle in human history. Among the German forces assembling is a unit equipped with a vehicle unlike anything previously deployed. Ferdinand tank destroyer. 90 of them, 65 tons each. 200mm frontal armor. An 88mm PaK-43 L-71 gun capable of penetrating any Soviet tank at ranges exceeding 2 kilometers. On paper, invincible. In the minds of the officers who requisitioned them, a war-winning weapon. In the experience of the men assigned to crew them, something else entirely. To understand what happened to the Elefant, you must first understand what Germany believed in 1943. They believed that technical superiority could compensate for numerical inferiority. They believed that heavier armor and bigger guns represented evolutionary advancement in armored warfare. They believed that defensive firepower mattered more than tactical flexibility. These were not stupid beliefs. They were supported by evidence. The Tiger tank had proven nearly immune to Soviet anti-tank weapons. The 88mm gun had established itself as the finest tank killer of the war. The logic seemed sound. Make the armor thicker, make the gun longer, create a vehicle that could sit at range, and systematically destroy Soviet armor before it could close to effective firing distance. The Elefant was the logical conclusion of this thinking, technical perfection pursued without compromise. What they had not accounted for, what the specifications and engineering diagrams could not capture, was that perfection in one dimension creates catastrophic vulnerability in others. The Elefant began as the Porsche Tiger, Ferdinand Porsche's competing design in the program that eventually selected the Henschel Tiger for production. Porsche, confident his design would win, had already manufactured 90 chassis before the contract was awarded to his competitor. Rather than scrap them, the decision was made to convert them into heavy tank destroyers. Remove the turret, install a fixed casemate superstructure, mount the most powerful anti-tank gun in the German arsenal, add armor until nothing could penetrate it. The result was a vehicle that weighed 65 tons, measured 6.2 meters long, stood nearly 3 meters high, and was protected by frontal armor up to 200 millimeters thick. Soviet anti-tank guns at standard combat ranges could not penetrate it. Soviet tank rounds bounced off like pebbles. In its intended role, sitting at range and engaging enemy armor, it was arguably the most lethal armored vehicle Germany produced. But it had no machine gun. This was not an oversight. It was a doctrinal decision. The Elefant was a tank destroyer designed to kill tanks. Machine guns were for close defense against infantry. The Elefant would operate at ranges where infantry could not reach it, supported by infantry of its own who would handle any close-range threats. This was the theory. The theory assumed perfect coordination between tank destroyers and infantry. The theory assumed visibility that would allow crews to see approaching threats. The theory assumed that combat unfolds according to plan. Combat, as the crews of Schwerer Panzerjäger Regiment 656 would discover, does not care about theory. The morning of July 5, 1943, the first day of Operation Citadel, the Ferdinands rolled forward into the northern pincer of the German offensive. Their mission: break through Soviet defensive lines, eliminate enemy armor, create penetration corridors for following forces. The initial results seemed to validate every expectation. Soviet anti-tank guns fired at ranges where their shells should have penetrated, and watched their rounds ricochet harmlessly. Soviet tanks that attempted to engage were destroyed at distances where they could not effectively return fire. By the end of the first day, the Ferdinands had claimed dozens of kills. The crews felt invincible. The commanders felt vindicated. And then the Soviet infantry adapted. They realized something the German planners had not adequately considered. A tank destroyer with no machine gun and limited visibility is effectively blind and defenseless against infantry at close range. The Ferdinands could see 12 degrees forward through their gun sight. Everywhere else, vision was restricted to narrow periscopes that provided minimal situational awareness. A man with a satchel charge, moving through smoke or using terrain, could approach within meters before the crew detected him. And once he reached the vehicle, there was nothing the crew could do. They could not traverse fast enough to bring the main gun to bear on a target at their own hull. They could not spray machine gun fire to suppress the threat. They could not even see him if he stayed outside their narrow field of view. They could only sit inside 65 tons of armor and wait for the explosion. Think about what this felt like. You are sitting in the most powerfully armed, most heavily armored vehicle on the battlefield. You have just destroyed 3 Soviet tanks at 1,800 meters, targets that never got close enough to threaten you. You feel untouchable. Then you hear something on the hull, metal on metal. Footsteps. You strain to see through the periscope, but the angle is wrong. You shout to the driver to move, but in the time it takes him to shift gears and engage the transmission, you hear it. The metallic clink of something being placed on the engine deck. You have 5 seconds to understand that all your armor, all your firepower, all your technical superiority means nothing against a man you cannot see carrying explosives you cannot stop. The Soviets exploited this weakness with systematic brutality. They learned to let the Ferdinands advance, then infiltrate infantry through the smoke and chaos of the battlefield to attack the vehicles from the sides and rear. They used terrain to approach from angles where the gun could not depress or traverse. They employed timed attacks, waiting until the Ferdinands were engaged with armor targets and their crews were focused forward, then rushing the vehicles with satchel charges and Molotov cocktails. The results were devastating. Within the first week of Citadel, dozens of Ferdinands were disabled or destroyed, not by superior Soviet armor, not by anti-tank guns that could penetrate their protection, but by infantry exploiting a vulnerability that should never have existed. But the absence of a machine gun was only the first of the Elefant's failures. The second was mobility, 65 tons powered by 2 Maybach engines, driving electric transmissions, a complex Porsche-designed system that was innovative and chronically unreliable. The Elefant's power-to-weight ratio was marginal. Its ground pressure was enormous. Its transmission was prone to failure. On roads, in dry conditions, it could maintain reasonable speed. In mud, across broken ground, climbing slopes, it struggled. And when it broke down, which happened frequently, it could not be easily recovered. The vehicle was too heavy for standard recovery equipment. Its transmission failures often left it immobile in place, and every broken-down Ferdinand became either a target for Soviet artillery or, if the crew could not repair it quickly, had to be destroyed by its own side to prevent capture. The crews began to understand something their commanders had not wanted to acknowledge. Survivability is not the same as protection. Protection is what happens when shells hit your armor and fail to penetrate. Survivability is whether you can complete your mission and return alive. The Elephant had extraordinary protection. It had terrible survivability. Because survivability depends on mobility, visibility, mechanical reliability, the ability to defend yourself at all ranges, the capacity to escape when the situation deteriorates. The Elephant sacrificed all of these for armor and firepower. It was optimized for one scenario, long-range anti-tank engagement, and catastrophically vulnerable in every other situation that battlefield chaos could produce. And there was a third failure, one that would prove even more tragic. The Elephant had no bow escape hatch. In most German armored vehicles, the radio operator or hull machine gunner had a hatch in the front glacis that could be used for emergency escape. The Elephant, in the pursuit of maximum armor protection, eliminated this. The crew of 6 had only 2 escape routes, the commander's hatch on top of the casemate and the rear casemate door. If the vehicle caught fire, if the engine compartment erupted in flames, as often happened when Molotov cocktails ignited fuel and hydraulic lines, the crew had to escape through the fighting compartment, past ammunition storage, through a narrow rear door while flames and smoke filled the interior. Many did not make it. Imagine being inside when it happens. The sound first, the whoosh of igniting fuel, then heat, instant and overwhelming, radiating through the metal. Smoke filling the compartment within seconds, thick chemical smoke from burning rubber and hydraulic fluid. You cannot see. You cannot breathe. You know the ammunition is stored along the walls, high explosive shells and armor-piercing rounds that will cook off in the heat. You know you have perhaps 30 seconds before the interior becomes unsurvivable. You scramble toward the rear, climbing over equipment, pushing past your crewmates who are also trying to escape. The door is small. Only one man can fit through at a time. You are third in line. The heat is searing now, the smoke choking. The first man is through. The second man is stuck, his equipment catching on something. You are behind him, feeling the temperature climbing, hearing the first ammunition starting to cook off, knowing that in seconds this metal box will become an oven, and the only thing between you and survival is a door designed without consideration for what happens when everything goes wrong. This is how crews died in the Elefant. Not from enemy shells penetrating the armor, although that happened. Not from catastrophic ammunition explosions, although that happened too. But from fires they could not escape, in a vehicle that had been designed with such confidence in its invincibility that the engineers never adequately planned for what happens when invincibility fails. By the end of Operation Citadel, after 2 weeks of combat, 40 of the original 90 Ferdinands were lost. Not 40% attrition from combat damage. 40 vehicles destroyed, abandoned, or captured. Some knocked out by concentrated anti-tank fire that found weak spots in the armor, joints, and hatches where protection was thinner. Some disabled by mechanical failure and destroyed by their crews. Some burned by infantry attacks that exploited the absence of close defense weapons. Some simply abandoned when they broke down and could not be recovered. The survivors were withdrawn, returned to Germany, and the recriminations began. This is where the story transitions from tactical failure to institutional denial. Because the Elephant's problems were not secret, the crews reported them immediately. The after-action reports documented every vulnerability. Commanders in the field sent urgent requests for modifications, specifically the addition of machine guns and improved escape hatches. The evidence was overwhelming and unambiguous. The vehicle, as designed, could not survive the battlefield conditions it faced. But institutions do not easily admit that their most advanced weapon system, the culmination of their engineering expertise, their commitment to technical superiority, was fundamentally flawed from conception. The response was characteristic of military bureaucracies confronting uncomfortable truth. Acknowledge some problems, make minor modifications, blame implementation rather than design. The Ferdinands were returned to Germany and modified. A ball-mounted machine gun was added to the hull front, operated by the radio operator, providing at least some close defense capability. Additional armor was welded to weak spots. The designation was changed from Ferdinand to Elefant, as if a new name could erase the trauma of Kursk. And then they were sent back to the front. The crews who had survived Kursk, who had experienced the reality of fighting in a vehicle designed by engineers who prioritized specifications over survivability, looked at the modifications and understood they were inadequate. Yes, the machine gun helped. Yes, the additional armor closed some vulnerabilities. But the fundamental problems remained. The vehicle was still too heavy, too mechanically unreliable, too limited in visibility, too catastrophic when it caught fire. The modifications were responses to symptoms, not cures for the underlying disease, which was that the Elefant represented a design philosophy that valued theoretical invincibility over practical survivability. Hauptmann Rudolf von Riesenberg, commander of one of the Elefant-equipped companies, wrote in his diary after returning from Kursk, "We were given a fortress and told to wage mobile warfare. We were given a weapon optimized for a battle that exists only in staff studies. We were given armor that could stop any shell and no way to escape when fire bypassed the armor and attacked the men inside." This is the psychological weight that accumulates when reality systematically contradicts what you were told. The crews had been assured they were receiving the most advanced tank destroyer in the world, ITI, vehicle that would give them overwhelming advantage. They discovered they had been given a vehicle that excelled at one specific task and failed catastrophically at everything else. A machine that prioritized engineering achievement over the practical needs of the men who had to fight in it. The trust erodes, not all at once, but in accumulating moments of betrayal, each fire that could not be escaped, each mechanical failure that left them immobile under artillery fire, each infantry attack they could not defend against because the vehicle had no machine gun. And yet the Elephants continued to serve. They were deployed to Italy, where their weight made them unsuitable for the mountainous terrain and fragile bridges. They were used in defensive operations on the Eastern Front, where their limited mobility made them vulnerable to being outflanked and encircled. They achieved individual successes. There are documented accounts of single Elephants destroying multiple Soviet tanks in defensive actions, proving that, in the specific scenario they were designed for, they remained lethal. But the cost-benefit analysis, the simple calculus of resources invested versus battlefield effectiveness, was damning. Germany expended enormous resources building 90 Elephants. The Porsche engines, the electric drive systems, the massive armor plates, the precision 88mm guns, the industrial capacity, the skilled labor, the raw materials. All of this to produce a vehicle that in actual combat conditions proved fragile, vulnerable, and difficult to sustain. Those same resources could have produced additional Panthers or Tigers or Panzerafos, vehicles with proven effectiveness and better operational sustainability. The Elefant was not just a tactical failure, it was a strategic misallocation of resources that Germany, fighting a war of attrition against enemies with vastly greater industrial capacity, could not afford. By 1944, the remaining Elephants were concentrated in a single unit, which fought in defensive operations in Poland and East Prussia until the vehicles were destroyed or abandoned during the Soviet winter offensives. The last recorded combat action involving an Elefant was in April 1945 near Berlin, where one of the final operational vehicles was used as a static pillbox, its mobility finally irrelevant, its main gun still capable of destroying enemy armor, its crew knowing that survival was now measured in hours, not days. When the war ended, no Elephants were left in German hands. Some had been captured and were displayed as war trophies. One survives today at the United States Army Ordnance Museum, one of only two remaining examples of a vehicle that was supposed to be unstoppable. Visitors look at the massive armor, the enormous gun, the intimidating bulk, and see power. The men who crewed them saw something different. They saw the distance between what engineers can create on drawing boards and what soldiers need to survive combat, between specifications that look impressive in procurement documents and the reality of burning alive inside a metal box, because someone forgot that invincibility is not the same as survivability. This is what the Elephant story teaches us about the nature of military technology and institutional thinking. It reveals how organizations fall in love with their own capabilities, how engineering achievement becomes confused with battlefield effectiveness, how the pursuit of perfection in one dimension creates catastrophic vulnerability in others. The Elephant was not a bad tank destroyer because German engineers were incompetent. It was a bad tank destroyer because it was designed to win a battle that existed primarily in theory, optimized for specifications rather than for the chaotic reality of combat, where the enemy adapts, where equipment breaks, where the perfect scenario never materializes. The men who designed the Elephant believed they were creating invincibility. They succeeded in creating a vehicle that was nearly immune to frontal anti-tank fire. But they failed to create a vehicle that could survive the actual battlefield, where threats come from all directions, where infantry exploit vulnerabilities that armor cannot address, where mechanical reliability matters as much as gun performance, where the ability to escape a burning vehicle determines whether technical superiority translates into surviving the war. There is a broader pattern here, one that extends beyond tanks and beyond World War II. It is the pattern of institutions solving the problems they want to solve rather than the problems that actually exist. The Elephant's designers wanted to solve the problem of Soviet armor. They created a vehicle that could destroy any Soviet tank at extreme range. What they did not solve, what they did not prioritize, was the problem of Soviet infantry with satchel charges, of transmission failures in mud, of fires in the engine compartment, of crews who needed to escape quickly when everything went wrong. These were not glamorous problems. They did not push the boundaries of technical achievement. They were mundane, practical concerns that matter more on the battlefield than all the armor and firepower in the world. Hans Frick survived Kursk. His Ferdinand No. 501 was knocked out by a shaped charge that penetrated the thinner side armor while the vehicle was engaging Soviet armor to the front. He and 4 of his crew escaped through the rear door. The loader did not make it out, overcome by smoke before he could reach the exit. Frick was assigned to a new Elephant in 1944, fought in Poland, and survived the war. In interviews decades later, he described the vehicle with a mixture of pride and bitterness. Pride because when it worked, when the scenario matched the design parameters, nothing could touch it. Bitterness because those moments were rare, and the rest of the time, the Elephant was a maintenance nightmare, a mobility handicap, and a death trap when infantry got close. He was asked once if he would have preferred to crew a Panther or a Tiger instead of an Elephant. His answer was immediate. In a Panther or Tiger, I would have felt like I was fighting a war. In the Elephant, I felt like I was trapped inside an engineering experiment that someone forgot to test against reality. This is the final irony of the Elephant. It was created by some of the finest engineering minds in Germany, designed with meticulous attention to armor angles and ballistic performance, built with precision manufacturing that represented the cutting edge of industrial capability. And all of that expertise, all of that engineering excellence, produced a vehicle that the men who had to fight in it would have traded without hesitation for something less advanced but more survivable. Because in the end, the purpose of military equipment is not to impress procurement boards or validate engineering theories. It is to help soldiers complete their missions and return alive. The Elephant excelled at the first part, in the narrow circumstances where it could be employed effectively. It failed catastrophically at the second part, which is why the men who crewed it remember it not as unstoppable, but as the machine that trapped them inside with no way out, when everything it was supposed to stop found a way through anyway. You can believe so deeply in technical superiority that you forget to ask whether the specifications you are optimizing for are the ones that actually matter. You can be so committed to creating the perfect solution to a specific problem that you ignore all the other problems your perfect solution creates. You can build invincibility on paper and discover in combat that paper, invincibility, burns just as easily as everything else when someone lights the match. The elephant was supposed to be unstoppable. It stopped itself.